Hey guys, welcome back. So I wanted to make a video on stress testing portfolios. So I came up with a script to get some estimations on how economic indicators or certain sectors affect a portfolio. So this is just a preliminary view on stress testing a portfolio. I know that it's much more complicated than what we will be doing in this tutorial, but it's something that's rarely talked about or that I have rarely seen here on YouTube regarding this topic. So all you're really going to need for this tutorial is just a return series of your portfolio. But if you don't have one, you can just quickly compile one, gathering data from Yahoo Finance. And I wanted to stress test my portfolio against certain economic indicators such as the unemployment rate, inflation, all the major sectors. And I wanted to see what actually impacted or could have an impact in my portfolio if, say, one of these indicators rise 10% or 50%, how would that impact my portfolio? And alternatively, if one of these economic indicators drops by 50% or 35%, how would that actually impact my portfolio? So I'll go through a number of economic indicators and just a couple of sectors, but I would recommend you go through as many indicators as possible to get a better understanding of how these impact your portfolio. So these are the packages we will be needing for this tutorial. So here I'm going to assign the tickers in my portfolio. So I'll just write TLT for long-term bonds, emerging markets, and the SPY. I'll send my data to a new environment, which we will be getting from Yahoo Finance by running get symbols, tickers. The environment will be E, and I'll do from 1970 0101. So I'll go ahead and run this line. All right, now that we have our data, I'm going to transform these from daily to monthly by running apply E to monthly. And then my portfolio will be do call merge apply E, and I'll extract the adjusted closes. I'll change the column names of my portfolio by running names of E. And then I'll calculate returns by running ROC of my portfolio, and I'll do type discrete. If there's any NAs in my portfolio, I'll set those equal to 0. And I'm going to make this portfolio equally weighted by running reclass core data of my portfolio, and I'm going to multiply that by C rep 1 divided by the number of columns in port by the number of columns in port. So that will be equally weighted. And then I'll do match 2. I'll do port. So I'll go ahead and run this line. I'll do call names of ports, and I'll set that equal to port. I'll save my index here by running index port. And then I'll remove E and tickers. So I save my index here because when we run linear models, I only want to start that economic indicator when my actual portfolio starts. All right, so now we're going to make a function called get port risk, and we'll do function, we'll pass in our portfolio, and I'm going to create a new environment to send all of these results to, and also a iterator. We'll set that equal to 1 so that we can name our output that we are sending to our environment called DAT. All right, so the first risk will be our market risk. So our benchmark will be GSPC or the S&P 500. So we'll run that line. I'm going to get the returns by running ROC. I'm going to extract the adjusted close, convert it to a monthly series, and then I'll do get symbols. I'll pass in the benchmark. I'll do from 1970 0, 1, 0, 1. I'll do auto assign false, and then I'll change the name to match our benchmark, and the return type will be discrete. So I'll go ahead and run this line, and I want to start my benchmark when my portfolio starts, so I'll do risk m index, and I'll send that to risk. So I'll go ahead and run that line, and then I'll do temp merge my portfolio with our benchmark. If there's any NAs in temp, we'll set those equal to 0. And then my linear model will be LM temp 1, which is our portfolio, tilde temp 2, which is our benchmark. So by running that, we can extract our beta, our alpha, and also our p-values. So I'm going to start by extracting our alpha, which is the return that cannot be explained by this linear model. And I'm going to annualize that and round it to 4 decimal places. So I'll do as numeric coefficient of our linear model. That's located in the first position. And then I'll multiply it times 12 to get the annualized return, and then I'll round that to 4 decimal places. So I'll go ahead and run that line. I'll extract the beta by running the same thing here, but my coefficient is located in the second position, and I don't need to annualize that. So I'll go ahead and run that line, and then I'm going to calculate the correlation between my portfolio and this benchmark by running round as numeric core temp 1 and temp 2. I'll round that to 4 decimal places. So I'll go ahead and run this line, and then I'll extract my p-values from this linear model by running cbind round cbind as numeric summary of our linear model $ coefficients located in the 4th column, and that's going to be the p-value for our intercept or our alpha. So we'll do 1 here, and then I'll copy this, and this will be for the p-value of our beta. I'll round that to 2 decimal places, and then I'll combine these 2 values. So I'll run that line, and then I'm going to assign. I'll do paste 0 risk, and then I'll do II, which is our iterator, and then I'll do as data frame cbind beta, our correlation, our alpha, the p-values, our benchmark, and a name of the risk type will be market risk. And then I'll do environment, which I'll send to DAT, which is the environment we created here. So if we run this line, we now have our results saved in this new environment. Alright, and then if you want to take a look at what the data looks like, we'll do DAT $risk1. Go ahead and view that. So here we have our beta, our correlation, our alpha, the p-value for the intercept, which is alpha, and then the p-value for our beta. And then we have our benchmark name, and then the risk type. So this is what the data will look like. So let's go back to our script. Go ahead and delete that line. I'll increment the iterator, and then I'll go ahead and run that. And then lastly, I'll remove risk, alpha, beta, correlation, our linear model, and temp. The next risk factor I'll do is the federal funds rate, which will be classified under interest rate risk. So then I'll do BM is equal to Fed funds. Our risk is equal to ROC. I'll do get symbols dot Fred. I'll pass in the benchmark. The environment will be my global environment. I'll do auto assign is equal to false, and then the return type will be discrete returns. So I'll go ahead and run these two lines, and I'm just going to copy this block because everything else will be the same. I'll just change this name to read Fed funds rate. So I'll go ahead and run this block, and then to view it I'll do DAT $risk2. So I'll go ahead and run this so I don't see any errors. I'll go back to my script, go ahead and delete this, and then I'll do one more. I'll do sector risk in technology. So for our benchmark, I'm just going to use the XLK. So I'll do risk is equal to ROC. I'm going to extract the adjusted close to monthly. I'll do get symbols, pass in the benchmark. I'll do from 1970-0101, auto assign, set that equal to false, and then the name will be the benchmark name, and then the type will be discrete. So I'll go ahead and run these two lines, and then again I'm just going to copy this code. And then I'm going to change this to technology sector. So I'll go ahead and run this block. So you're going to repeat the process until you get all the types of risk that you want to compare your portfolio to. And then once you're done, I'm going to rbind all the results together by running do call. I'll do rbind. I'll do mget names in the DAT environment by using my DAT environment. So if we take a look at all, now we see all the results are binded together. I'm going to change these last couple of column names here. So I'll do call names of all for columns 4 through 7. And I'll run pval of alpha, and then I'll do pval of beta, and then I'll do benchmark, and this will be the risk or the risk type. And then finally just return all. So if we take a look at that data frame one more time, we see that the column names have changed. Alright. So now I'm going to go ahead and run this function. So now I'm going to use this function by running get port risk, and then I'll pass in my portfolio, and then I'll run all order, all alpha, decreasing, set this equal to true. So now I'm going to plot this in a 3D plot by running plot underscore ly. X will be all beta. My Y values will be tilde all $ correlation, and then my Z values will be tilde all $ alpha. I'll do type, we'll do scatter 3D, we'll do mode, we'll use markers, and then color will be all risk. So we'll go ahead and run this line. So you can zoom out by scrolling on your mouse, and then we can also move this around. So here it looks like the federal funds rate is not correlated with my portfolio, so therefore the beta is close to 0, and we have about 7% alpha according to the linear model. So for the technology sector, it looks like it has a positive correlation. Our beta is almost 28, and then we have positive alpha of almost 6%. Now lastly, we're highly correlated to the market, almost 80%. Our beta is half, and our alpha is almost 4%. So what's cool about this is that you can move this around. Alright guys, so that was for the visualization. So I'll go ahead and close this plot out. So now I'm going to be using the capital asset pricing model to extract what our expected portfolio value is by inserting a market return of our choosing. So I'll have to build a function, and I'll name it expected return. By running a function, I'll pass in the market return, our risk-free rate, and our beta. So the CAPM is basically the expected return of our portfolio is equal to the risk-free rate plus beta multiplied by the expected market return minus the risk-free rate. So I'll go ahead and round the values to 4 decimal places. I'll run this function. So now for the stress test, I'll set the expected market return equal to negative 0.25 or 25%. So I'll do all. So I'll insert a column and I'll call that down. Will be equal to expected return. And then I'll set the risk-free rate equal to 0.0075, which is around 0.09% annualized. And then I'll set the beta equal to, as numeric, all beta. So we'll go ahead and run these 2 lines. Take a look at all. Alright, so according to the capital asset pricing model, if the federal funds rate decreases by 25%, my portfolio should go up by roughly 1%. But then we see that the p-value for this beta is almost 86%, which is highly unreliable. The smaller this number is for p-value, the better, and preferably you want to see less than 5%. So again, this just tells me that this beta is unreliable, and I would explore other models if I really wanted to measure what the risk is against the federal funds rate. Now for the next 2, the p-values are 0, which is great. So if the technology sector falls by 25%, my portfolio should see a decrease of almost 6%. And if the S&P 500 falls by 25%, then my portfolio should fall roughly 12%. So let's go back to our script. So I'll make another function to answer the following question. So what would it take to make my portfolio lose a certain amount? And again, we'll make this 25%, or let's make this 50%. So my function name will be EL for expected loss, and I'll do function. I'll pass in the return of my portfolio, the risk-free rate, and the beta. Alright, so I'm going to be using the capital asset pricing model again, and I'm just going to rearrange the variables to get the expected market return by running beta minus 1 multiplied by the risk-free rate, and then I'm going to add the expected return of my portfolio, and then I'll divide that by beta. So again, I'm just rearranging this line here, and then I'll round the expected return of the market to 4 decimal places. So this should be beta. So I'll go ahead and run this function, and then I'll make the expected return of my portfolio equal to negative 0.5, and then I'll do all, down, and then I'll use this function by running EL. ERP is equal to ERP. My risk-free rate will be equal to 0.0075, and then beta will be as numeric, all beta. So we'll go ahead and run these two lines. We'll take a look at all. So again, the federal funds rate is basically unreliable at this point. So according to the capital asset pricing model, we see that it would take XLK to drop by negative 182% to make my portfolio drop by 50%. Similarly with the market, it would take the S&P to lose about 100% to make my portfolio fall by 50%. So again, I know that there's better models out there for stress testing, but this is just for you to get an idea of how these risky assets move along against your portfolio. Alright guys, so this concludes this video. I hope this was informative. And again, this is just preliminary. If I find a better way to stress test portfolios, I will show you guys. But for now, this is just a rough estimator. So again, thanks for watching, and I'll see you guys in the next video.